Hi, and welcome to How to Improve Science Performance Through Strategic Note-Taking.
This begins our lesson on Newton's second law. Who was Newton, you may ask? Sir Isaac Newton was a great scientist and mathematician. His greatest discoveries were of the law of gravity and the three laws of motion. Newton was able to describe motion of all objects using these three laws. We recently covered Newton's first law. We will now discuss his second law of motion. Newton's second law states that the acceleration of an object depends on the mass of an object and the amount of force applied. Basically, you should know that things move faster or slower depending on their size and how much force is applied to them. Before we learn anything new, let's review the terms mass and force. You should remember mass is the amount of matter that an object takes up. At this time, you should be able to recognize that the symbol used to represent mass in scientific formula is a lowercase letter m. The unit used by Newton to measure mass is the kilogram, whose symbol is a lowercase kg. Newton's first law was the law of inertia. This is a reminder, so you should know inertia is the resistance to change. So be sure to write down that inertia is the resistance to change. The greater the mass of an object, the greater the amount of inertia, or resistance to change in motion. The lower the mass of an object, the less inertia it has, meaning it is less likely to resist change. So large masses have more inertia, or resistance, than less massive objects. This is a review, but each of you should remember, force is a push or a pull. The symbol used to represent force in scientific equation is a lowercase letter f. The units used to measure force are called newtons, represented by an uppercase letter N. The unit comes from Sir Isaac Newton's name, so we use a capital letter for this symbol. Newton's second law states that force is equal to the mass of an object times its acceleration. It is important to remember Newton's second law and the formula used to represent it. F is equal to ma. So again restated, F, or force, is equal to m, which is mass, times a, the acceleration. This formula can be used to calculate how much force must be applied to an object to accelerate its specific mass. Let's quickly review acceleration. We covered this a few lessons ago, but you should know it, remember it, and be able to use it. Acceleration is a measurement of how quickly an object is changing velocity. The symbol for acceleration is a lowercase a, and the units used to measure acceleration are meters per second, or meters per second squared. You should understand what F equals ma means. What it basically means is that the force of an object comes from its mass and its acceleration. So again, the force of an object comes from its mass and its acceleration. What does that mean? Write this down. Force is directly proportional to the mass of an object and its acceleration. Force is directly proportional to mass and acceleration. What this means is that as one variable increases, so does the other, and vice versa. If one variable decreases, so would the other. Take a look at the following example. The same truck is shown here. In the first situation, a large force is being applied to the truck, and as a result, there is a great acceleration. The second example has the same truck with the same mass, but only a small force is applied. As you can see, there is less acceleration. So as force increases, so does acceleration. And as force decreases, so does acceleration. There is a twist to all of this. Please note, acceleration is inversely related to the mass of the object. That means when the same force is applied to an object with a smaller mass, it will have a greater acceleration than an object that is very massive. So inversely related means as one variable increases, the other variable decreases. They are opposites. As one increases, the other decreases. That is what inversely related means. Check out this example for better understanding. Here are two objects, one with a low mass, a bullet, and another with a high mass, the dinosaur and roller skates. The same force is applied to both objects, but look what happens when the force is applied to the bullet. Its acceleration is great, but when the same force is applied to the dinosaur, its acceleration is very low. This is due to the much larger mass of the dinosaur versus the bullet. So this example shows when a force is applied to a small and a large mass, acceleration differs. Let's take a look at an example of finding force using Newton's first law and the formula F equals ma. We need to solve for the force required to give a 6 kilogram block an acceleration of 2 meters per second squared. In order to do so, you must use Newton's second law of motion and multiply mass times acceleration. So plug in 6 kilograms times 2 meters per second squared. By doing so, you get 12. So that is the force needed to move this object at 2 meters per second squared. So 12 newtons of force is needed to accelerate this 6 kilogram box 2 meters per second squared. Review the vocabulary pulled from Newton's second law. You should have these terms in your notes, so please check, and if you haven't, please record them now. Mass is the amount of matter in an object. Inertia is the resistance of change. Force is a push or a pull. Acceleration is how quickly velocity changes per unit of time. And don't forget direct and indirect relationships. Directly related means like results. If one variable increases, so does the other, and vice versa. Inversely related means opposite results. One goes up and the other goes down. This concludes our lesson on Newton's second law.